Okay, welcome to IQ online class. Okay, so today we are solving 2023 April May Science Laboratory Technology Level 2. So this question is question 4. So we just picked one question, question 4, question 4a. Okay, question 4a. So the question reads: evaluate the following with respect to x. Evaluate the following with respect to x. So the first question A2 is integral of x exponential 5x dx. 2 is the integral of x squared, in brackets we have 3 minus 10x to the power 3, everything raised to the power 4 dx. So here we want to integrate this function here. So the function is integral of x exponential 5x there. What do we do? What formula are we going to do here? The only possible formula we can use here is integration by parts. So the formula for integration by parts is derived as, or is given as, won't derive it. So it is given as integral of u dv. This is equal to uv minus, okay, integral of v du. Okay. So now having done this, okay, or having gotten the formula as the formula for integration by parts, okay. So now from this one, you can see that this expression is in that form there, okay. So now, which one are we going to pick as u, and which one are we going to pick as dv? So from this expression which we have, which is integral of x exponential 5x. Okay, so now we have two functions, the function of x and the function of exponential 5x. Which one here will be our u and which one here will be our dv? So always the u part is the part which gives you a 0 when you do successful differentiation. Okay, so when you do successful differentiation on x here, at some point you can get a 0. So that's the function which you get as u. So u here is equal to x. Okay, then the other part is now our dv, which is exponential 5x. But from the formula here, we need v, we also need du. Okay, so from this function here, okay, from this function here, we can pick our du. So this is du, okay, is equal to differentiate x. Okay, differential of x is just 1. So this is 1. Since we are differentiating with respect to x, we'll attach the x like this. So meaning our du is same as 1 dx, okay, or just the dx there. Okay, so let's keep an answer there. Then here, what else do we need? We need v. Okay, now since here we have dv, okay, so in short, this function here was differentiated. So to get v, we are going to integrate it. So here, v, so our v is just integral of exponential 5x here. Okay, so meaning v would give us okay. So this one we are going to use a common integral. Okay, so the common integral which we are going to use here, let's take for instance when you have exponential ax. Okay, integrating this one takes us to 1 over a exponential. You get everything the way they are there, in this case ax. So we are going to use this common integral here to integrate this function here. Okay, so our a in this case is 5. So here the integral of exponential 5x is same as 1 over 5, then exponential 5x. Okay, now that we have v, u, du, and dv there. Okay, so we can come back, okay, on the formula there and we substitute what we have found. Okay, so just demarcate this part here. But okay, so our formula is let's get this one. Okay, so our formula is integral of u dv. This is equal to uv minus integral of v du. Okay, so integrating this one. So integral of x exponential 5x. This will be equal to our u. The u which we have found here is x. So x here, v, the v part is this one here, the one which we integrated there. So x is going to multiply 1 over 5 exponential 5x there. Okay? This is minus here. Then the integral of v part. V part is 1 over 5. Then this is exponential 5x times du there is 1 dx, which is just same as just dx there. Okay, so by doing this, okay, this is same as x times 1 over 5 will get 1 over 5 x exponential 5x. This is minus. There we have multiplying that one there. Okay, this one will give us integral of 1 over 5 exponential 5x exponential 5x dx there. Okay, so now we cannot leave the answer there. We are integrated, so we don't need an integral symbol in the answer. So this one is still equal to, we'll get that one the way it is. This is 1 over 5x exponential 5x, okay, minus, okay, we can get the constant out of the integral symbol here. The constant which we have there is 1 over 5. So this is same as 1 over 5 integral of exponential 5x, okay. This is the x, okay. Now that we have this one which we can integrate from the common integral, okay. So, but of course the answer which we get here will multiply 1 over 5. So what we have, this is equal to 1 over 5 x exponential 5x minus 1 over 5. So this will multiply. Again, what is the integral of exponential 5x? So exponential 5x, the integral is, using the common integral, you say 1 over 5, then exponential 5x. Okay? So like that. So here you attach a constant there, which is c, because this is the end. Okay, this one has given, we have arrived at the common integral. So once you integrate that one, you attach the constant. Why are we attaching the constant? This is an open integral or indefinite integral here. We are not given the limits. So here, the final answer now for integral over x exponential 5x is equal to 1 over 5x, okay, exponential 5x, okay, minus 1 times 1, this one will give us 1 over 2, rather 5 times 5, this is 25, okay, exponential 5x plus c. So this is the answer, okay. We have integrated this function here with respect to x, okay. Now, we have integrated that. Just a quick one. There is integration by parts. Now using what we call tabular method, where we compare the answers. This one is real quick. Okay. So using what we call tabular method or DI method, okay, again you get two functions, okay, you are integrating the same part, okay, this one. So using what we call integration by parts tabular method, okay, integration by parts tabular methods, okay. So here you get two functions. One function will be differentiating, the other function will go at integrating. So like in this case, you always differentiate the function which gives you 0 after successive differentiation. So in this case, the function which we have here is x. The function which we have there is exponential 5x. Okay? So now we are going to differentiate this. Differentiating this one will get 1. Integrating that one will get 1 over 5 exponential 5x. Okay? Again, we are going to differentiate that one. It's a constant to give us 0. Differentiating that one will get 1 over 25 exponential 5x. Okay, so this is 1 over 1. Okay, again it will multiply when you integrate. This is 1 over 1. So this is where now 1 over 5 times 1 over 5, you get 1 over 25. Then when you reach here, of course this one is always positive, negative, positive. Okay, after doing this, this is real sharp. After doing this, you are going to multiply the diagonals. Okay, of course including the sign there. So when you multiply the diagonal here, x times what we have differentiated there, in short, integral of x exponential 5x will be equal to If the first part here is x times 1 over 5 exponential 5x. So this will be 1 over 5x exponential 5x. Okay? We have 1 here, including the sign. This is negative 1 times 1 over 5. So this one will give us negative. So this is minus 1 over 25 exponential 5x. Since we are done there, okay? If we had integrated this one, we have gotten 0 times whatever we get here is 0, so you end here. So since this is what you get, you attach the constant there. I'm trying to see that the answer which you have gotten here is the same answer which you have gotten there. Okay, so this is what we call DI method or differentiation by parts tabular method. This one is differentiation by parts. Okay, this one is DI. That one is differentiation by parts, but they are all under by parts differentiation there. Okay, so having done that, those are the answers. Okay, so we're going to move to the second question. The second question which we have there is integral of. You have to bear in mind that every time you are integrating, make sure you go to the common integral. Okay? Make sure you arrive at the common integral here. So what we have here, question 2 here is the integral of x squared. This is 3 minus 10x to the power 3 raised to the power 4 dx here. So in this case, we are going to use U-substitution. Again, which one will make U? Which one will make U? So here, this function which is raised to the power 4 there will be U there. Why are we interested in this one? Because when you differentiate this, as I'm going to get x squared in the differential for this one, which will cancel that x. Okay? So what we'll do is we are going to say let U be equal to 3 minus 10x to the power 3. Like that. Okay? Then after that, what you do? You are going to find du, okay? Du dx there. So this is same as du is equal to the derivative of the constant there will give us 0. Differentiating this one from the power group is 3 times negative 10, you get negative 30. Lessen the power there by 1, you get 2 there, okay? So since we are differentiating this one with respect to x, you are attaching the x there, okay? Now from here, okay, let's take this answer. So when you go back to our expression, we find that integral of x squared is, okay, this one is u now, okay? But since all this is raised to the power 4, even what we get here, u should be raised to the power 4. This is what? Dx. Now, since we are doing what we call integration by U-substitution, we need to get rid of x. What do we do? So we come back here, okay? We have du is equal to negative 13x squared dx. So from here, let us make dx the subject of the formula. So making dx the subject of the formula, we are going to divide negative 13x squared both sides, even here negative 30x squared. That this one and that one there. Meaning our dx is equal to du over negative 30x squared. Okay? So having done this, okay, we know our dx, so we can come back here and substitute. Let me just do it here real quick. So we'll come back there. We have integral of x squared, okay, u to the power 4 times it. Where is the x, we put du over negative 30x squared there, okay? I'm sure you can see that since we are multiplying there, this x squared and that x squared can cancel. So you remain with the integral of u to the power 4, okay? U to the power 4 over negative 30, okay? Du, okay? So here now we'll be integrating this one with respect to u. We don't have any what? X there. So now, I agree that, or hope you understand that there or here we have what? 1. So this is 1 over negative 30, which we can take out of the integral symbol. So this is same as 1 over negative 30, okay, integral of u to the power 4 there du, okay. Then this one is a common integral which we can work with. So this one is, we are going to use power there of integration. So let's maintain 1 over negative 30 the way it is, okay, times it, okay, integrating this one. This is u to the power 4 plus 1 over 4 plus 1 there, okay. So this one plus c, okay, because this will be the end of the integration there. So now this one, integrating that one, will get, okay, this time that one will get, so this time that one will get 1 over negative 30, okay, times this is u to the power 5 over 5 there, okay, of course plus c, okay, of course plus c there, okay. So this is 1 times u to the power 5 is just same as u to the power 5 over negative 30 times 5, this one will give us negative 150, okay, so plus u there. You can't leave your answer here. You can't leave your answer here. You know u, the one which you made there, u was this one. So, meaning final answer, okay, final answer. Since we are integrating this one with respect to x, we should have x, not u in the balance. Meaning integral of x squared, okay, this is 30 minus x, minus 10x to the power 3, everything raised to the power 4, the x there is equal to, where there is u, I'll put the u part which we let at first in this case, 3, okay, minus 10x to the power 3, everything now raised to the power 5 there, over, okay, over negative 150, okay, plus c there. So by doing this, you have integrated this part here. So this is the final answer. Okay, thank you for watching, and more videos are coming on the same paper. We choose more questions. Okay, we choose more questions on this paper, 2023 April, May.